This has been a wonderful symposium. I'd like to say thank you especially to all of those who helped out, the CERIAS staff, in particular Randy Bond, Joel Rasmus, Joe Maslin, Lori Floyd, Marlene Bells, Marlene Walls, Ed Finkler, Ed Cates, Adam Hammond. All have just done a tremendous job for us. One final announcement regarding the symposium. We have a poster contest every year where we have a panel of distinguished judges who go through and look at the posters for originality, for presentation, and in talking with the students, your ability to understand what it is you have on your poster. It's not a given necessarily. But there are some recognitions for these. The number 3 poster was the poster on printer security and forensics by Michelini, Kana, and Delp. And you will be receiving a certificate of acknowledgement for that. The number 2 poster, optimal finger combinations and multi-finger biometric systems, Marvin Michaels, Shimon Modi, and Stephen Elliott. And for the student involved, there's a $100 certificate prize along with a certificate for that poster. So congratulations on that. And the number 1 poster, as judged by our panel, automatic reverse engineering of data structures from binary execution. And this was Lin, Zhang, and Zhu. And the student involved here gets a $250 prize and a recognition certificate. So congratulations to all of the students who participated. So in selecting a speaker for today's seminar, we had some fortuitous circumstances, but also some direction. And part of the direction was who could provide an interesting and deep technical perspective on the field. Information security is a young field in some respects, but does have some rich history. And as I've said in several meetings and classes, there's a lot that occurred before Google came along. And if you can't find it in Google, you may not think it exists, but it does. And there are some people who were laying the groundwork for that. Our speaker today is Dr. David Bell, who has had a long career in the field. He's one of the few who's had his name immortalized of sorts in one of the things that we all learn along the way, the Bell-Lapatula model for information flow and a system to maintain confidentiality. But he has actually had an influence in a number of other areas, including development of some of the documents in the Rainbow series and common criteria, development of secure systems and testing, and a number of other things. I'm not sure how many of which he can talk about, but are not going to be necessarily the topic of his talk today. Dr. Bell got his PhD at Vanderbilt University, and then went on to a career that included 3 separate instances of working at MITRE, a place just couldn't seem to get away from. And in between, he spent time at some government agencies, startups, and an independent consulting firm. Turns out we had a number of mutual friends who were on that. We were just talking about it. He has since retired, in the sense only that he doesn't go to work every day at a place that has deadlines and requirements, but he continues to be very involved in security and writing, in speaking before groups, and in thinking about some of the hard problems. We're very fortunate to have him here today to share with us some of his thoughts on security, and in particular, how everything he needs to know about security he learned in 1974. So please join me and welcome Dr. Bell.
Jane, is this on?
Yes.
Oh, okay.
It's just for the camera.
Oh, it's for the camera. Okay. Good afternoon. Should have gotten. So, This is a talk that I first gave last May. A friend of mine, Blaine Burnham, got me to go out to Omaha, and I wasn't sure what to. He bribed me by promising to have my talk the same weekend as Berkshire Hathaway's stockholders meeting, which I'd wanted to go to for years. So I wasn't sure exactly what I wanted to talk about, and this Robert Fulghum essay poem thing, everything I needed to know I learned in kindergarten. And it kind of stuck in my head and I couldn't get rid of it, so that I ended up sort of structuring my talk around this. I've given it several other times with only minor modifications. For all of you who are currently connected and really want to go look at this, if you point yourself at offthisweek.com/talks, there's a list of talks, and the first one there is CERIAS 2010. That's actually what I'm driving here. The reason I say that is that on the last page, my parody of Fulghum is available. It was up here just a second ago. Now, the first thing you might think when you see a title like that is, what in the world can he be talking about? Look at everything that has changed. The speed of things, the speed of our computers, our cycles have changed. We went from big iron to little tiny computers. And the diagram in the top right is an actual map of all of ARPANET in 1974. You could count them. The picture at the bottom is the internet as mapped in 2005. I tried to find an update, but I was unsuccessful. So what I really mean is not that things have not changed, but that the principles underlying the whole issue of security have been remarkably constant. Now there's another footnote, which is when I say I learned it, I mean somebody in the community learned it by /74 and eventually I found out. A number of these things were available in 1974, but I had not taken the time or had the opportunity to go look at it. During the time from 1974 till I retired the second time in 2005, there was only one fundamentally new thing, my opinion, that came up. Everything else was old wine, new bottles. So here's my career. Most times people think of me as a person who just did modeling all of his life. There's a whole career. That big dip there near the end, that's the first time I retired, 2000. After the attacks, I unretired and worked for 3 years. So that's the career. You'll notice that I spent most of my time doing security, but the little red thing, there was a bunch of modeling early on, and then it tailed off, hardly any. I mean, every once in a while someone would say, you know, we need modeling work, and we'd look at the toolkit and decide, no, what we've got's not quite right. So you need to go off and do something. So my view of the important principles of security came from that early modeling work. But it informed my entire career. The things I had to learn to do the modeling, the things that Len and I did together were the basis for most of my career. Now, on the other hand, see the little red dot? At that point, that was 1983, I had spent 8 years not doing any security at all. And at that point, security was a minor part of my career. Well, at that point, as I mentioned one time jokingly in a description to be used in an introduction, I was seduced back into the field by Roger Schell and Marv Schaefer. Much to my chagrin, they printed it in the proceedings. And I went off to work at the Computer Security Center. So, though everybody thinks of me as a modeler, I think of myself as a security dude. Now, when I came into the security field, which was '71, I looked at the field and I had the same reaction I had for a number of other fields. All the good stuff has already been done. I will never catch up. Now the things that had been done by this time, one of those three I actually knew something about. The Ware report and the Anderson report, I only became aware of their implications later. But I did read some of the Multics papers from 1965 where they're trying to build big iron and do protection. And many of those papers are the classics. I don't know if you can find them on Google, but if you can't, you should get a piece of paper that has them written down. They're extremely important. Reading about how protection in safe deposit boxes with diamonds will help you avoid the mistake of believing you can protect things smaller than the container you've got them in. I'm not going to talk much about the Multics papers. That was actually the best kind of stuff that was out there that talked about security in an abstract kind of way, but it was tied to a particular operating system, the Multics operating system. The other two things I will talk a bit about, the Ware report was published April 1970. The Glaser panel that was put together by the Air Force, who was executive agent for computer security for the Department of Defense. Their job was to figure out computer security for all of DoD. The Glaser panel was put together to try to put together a plan of action for computer security. And one of the driving forces behind wanting to do that was that computers are expensive. Really expensive. I did a retrospective some years ago where I actually dug up the information, and I pointed out that in those days, your standard computer, the IBM 360, and I'll get the following letters wrong, and I compared it, how much memory it had, how much storage it had, and then I pointed out that that computer cost $30,000. That's the rental cost every month. They're so expensive that the military services wanted to be able to buy one big computer and do the weather over here and the intelligence summary over there, but they were concerned that some of the intelligence might end up in the weather summary. So they put together the panel to do a number of things. One, to see if they could use commercial systems as they existed, and the other to make a plan about what to do. The most significant chunk of the Ware report, to me, was this diagram, which shows network vulnerabilities as of 1970. Now, I'm sure this is hard to read for you, but you've got radiation, you have taps, you have improper connections, you have access control, you have replacing the supervisor, you have, where did those go? There were recorders on remote consoles. In the large sense, if you abstract from the pure technology that they're talking about, that's a pretty good description of what people can do to you that's evil on the network. Now, one of the interesting things to me, we had a bit of a conversation about classification at the panel this morning, security kinds of things being classified. The Ware report was classified confidential. In the introduction, it has this interesting statement. Any good research library would allow you to reach all of these conclusions, but since government employees were involved, just to be on the safe side, we're going to classify it confidential. Not the opinion I would take. Now, the Anderson report, one of the most important things to me, to my education, was something I didn't learn about until 1980 or so, but what they had done was to fund a number of tiger teams, which term we still use, to go off and see if they could break into commercial systems. Well, and the answer was, every time we try, it works. But it was worse than that. Penetrators are almost as lazy as mathematicians. You point a bunch of penetrators at system A, and they find 5 ways to break in. they have a little congratulations, some high fives, and you assign them to System B. What should we do? They worked last time. We should try it again. Amazingly, they almost always did work. The same problems started appearing in different contexts everywhere you went. I am told there was a time when they were teaching people how to do penetration testing because they were going to be evaluators, and they decided in the same fashion, this is going to be close hold, we're not going to tell people how to do it. I am told there were about 10 or 12 sort of basic things that people always tried, and most of them worked on every system they tried. So not only do they fail, but you don't have to work very hard at it. As long as you've got the dozen down, it's going to go off and work. So if that's the case, who here is familiar with Ken Thompson's Turing paper on trusting trust? Oh, good. Did you ever read his revised version that he put on his website? In the original one, he said, I read about this somewhere in some Air Force report. If anybody knows where I got it, that'd be nice to know. Roger Shell knew where he got it because Roger Shell did it. Part of what they had done was break into that. When they were breaking into the system, they did a number of things. What they found was if you break into the system any one of 5 ways, the full credit answer is deposit a bunch of backdoors that people can't find, like the Thompson backdoor, which is, in that case, what you did was a couple of steps to make sure that the login program always let you in if you said JSON, or whatever your favorite term was for getting in, and that you couldn't compile it away because you'd bug the compiler as well. Well, they had done similar things. They broke in, they put in some backdoors, and then they got the Good Citizenship Award by reporting the first problem. And so false sense of security happened, and they still had their backdoors, and they put their backdoors in so you can't find them by looking at the source code. Okay, so what do we do? Commercial systems don't do it by themselves, and penetrate and patch is going to fail. Well, the answer was, we are going to have to design this thinking about security ahead of time so that we have a shot. And what they actually said what they wanted to do several different ways, which were not always compatible. First, we have to define what we're doing, and then we need a conceptual design, and they said, and that's what you call a model. Now, I read this, like I said, thoroughly in about 1982. In 1972, the new fiscal year came, and MITRE had this big contract with the Air Force. It was a major contract, projects, sub-projects, tasks. So Len Lapatula and I, we saw this task, and they called us in, and we said, we'd like you to work this task. So the task was kind of terse, and it had a number. The description was, you will write a report. The name of the report is Secure Computer Systems. The topic will be a mathematical model of computer security, full stop. Now, they gave us 1.5 staff years in 12 months. More than anyone would do today, I suspect. I didn't know that this fit into a grand plan. They just said, go build a model. Well, they didn't tell us what security was. They didn't tell us what a model was. They did want it to be mathematical, whatever that might mean. So, what was a model? That was one of our things. The other one, we had a couple of things. I think I have done something evil. I've just disconnected. Oh, no, okay. Are we okay? Mr. AV guy? Lord. I always used to say that techies can't go to dinner. They can't decide where to go. Can't make a decision. Apparently techies can't deal with microphones either. one of the things we had to figure out was, how can we tell when we have a model? We looked at the literature, and there was the multics stuff, but mostly it was talking about multics in general and in great detail. There were these registers, but there were some examples that were called a model of a system, but they were a generalization of a particular system. I mean, the biggest example to us was the ADEP 50, that Carl Weissman paper, forgot where it was published, but it was a system that SDC had built. And so they had a system, and then he abstracted that description to talk about sort of the principles that they were doing, and that's where we came up with high water mark. That's probably out of date. Nobody knows that anymore, huh? Well, that didn't seem good for us because they didn't tell us model a particular computer system. They said all security in computers. So we didn't think that was so good. Our view was that what you needed was a tool that would help you either analyze something you've got or help you guide you as you were trying to design it. So we viewed it as kind of a toolkit. Now, in later times, sometime in the 80s, there was an evil period in my life that I refer to as the model wars. I always used to say that one of the problems in computer security was that we never criticized each other's work in public, with one notable exception, which was that Len and I got savaged every time we turned around. Well, we got savaged one time, and one of the leading proponents, his notion was that a model should delineate exactly what security is. So it would tell you what you had to do, and it also would prohibit anything that anyone thought shouldn't happen, which is a little bit beyond computable as far as I'm concerned. So we had a bit war about that. And I am not interested in talking about the modeling wars, but I did want to mention that there is that other view. We went with model as a tool. Beyond that, our notion for what it was that we wanted to be able to do in building a mathematical model was, well, we knew we had to describe the situation. We had to be able to say computers, and all of the stuff that made up security. So we needed classifications and clearances. Our analog to start with was people have documents. Documents have classifications. People have clearances. Classifications and clearances look like this. Sometimes, even if you have a clearance, you can't see it, and you have need to know. There were compartments. So we had to be able to take all of that stuff that people were expecting when they thought about classified documents, and they had to be able to see it reflected in the model. So we had to be able to describe it. And beyond describing the bits and pieces, we needed to be able to say, here's our definition of security. Some of the other papers in security talked about security without defining it. And then when people wrote letters to the editor, what they ended up saying was, there's a problem because my pet theory hasn't been treated. And we decided, okay, we're not going to have that complaint. We're going to define it. The security is this. So if you want to criticize us, there are two things. You can say, you made a mistake in logic right there. Or you can say, something I care about you didn't treat. And in the latter case, we would say, be our guest. There must be a paper in that. You could go write something. Of course, a couple of times, the person that said that was our boss. So we said, yes, sir, and off we went. So you describe it, and then you want some results that actually give you the kind of guidance, limits, aid and assistance. But it's an ivory tower if you don't take that general result and apply it where somebody can use it. Now, later in life, remember when I was not doing security? I was in a hole in the ground in Germany, in a command post. I cared about systems in the field. This is an early precursor, I guess. Coming up with modeling results that are up here that nobody can ever use and go someplace is an academic exercise. Well, that's not quite what I meant here, is it? it's an exercise that doesn't have concrete implications. And I like concrete implications. That means that you're off doing something. So that's what we decided we wanted to try to go off and do. You know what I forgot to do was to set my alarm to remind myself not to be too late. So we went off to do this. Now, a number of people have mispronounced Len's name. When he grew up, he was Len Lapatula. He went off to college in the Jesuit called roll and said, "Mr. Lapatula," and he liked it. So he was all of his family was Lapatula, and he was Lapatula. He was senior. He was the senior staff, and he had the perfect right to have his name first on our first volume. But he decided, for whatever reason, we were going to go alphabetical, and we'd alternate. So, wrong place. The first one was Bell and Lapatula, and there's the mathematical foundations. And it laid out a framework for describing things, and it has the first basic security theorem. Well, there's a story behind this, but I'm behind. I'll tell you afterwards. The next one, a mathematical model, that was Lapatula and Bell. And you'll notice that the state components, the definition of security, the state transitions, and the theorem that helps you analyze have all changed. Well, and part of that was because, we made our first foray into it, and then we found that there were, things that we knew we hadn't done and we needed to add. But viewing this as a toolbox, what we did was buy a basic toolkit, and then we started adding additional tools that we needed. Then Len abandoned me and went to support NASA in Houston. So volume 3 was Bell. And once again, everything changed. And then I thought it was, we thought we were done. Len came back, and a year passed, and they came to us and they said, they're in the process of securifying multics, and when we look back, all of your definitions keep changing on us. And we're not sure how to proceed, in addition to which there's this enormous gap between the multics design and your theoretical stuff. So there's this big job of bridging that gap, and we don't want to give it to the engineers, we want to give it to you. So they said, come back, give us a unified exposition, and write us an interpretation for multics. So we came back and we decided the first thing we needed to do was talk to the engineers about what a multics was. And they said, we're busy. They pulled out a copy of Elliott Organics Multics, a study, an examination of its structure. I forgot the title exactly. They said, read this. Don't bother us. Well, for an abstract mathematician, and reading organics book on an operating system was really hard. I had never taken a computer science class, but it was kind of a self-education. I learned a lot of good things. In fact, in later years, when someone would say, we need you to write a model for this system, I'd say, fine, where's organic? It turns out, for other operating systems, there isn't an analog of organic. So off we went to go do this, and we did this. Now, these sets of rules, which are actually kind of governors for particular changes of state, are not all the same. We got rows up here and R's down here. We got tired of having to put rows in place. Now, these are not obsoleted. They're still available, and in fact, in later life, the multics specific ones were less useful than some of the earlier ones. So, off to do modeling work, we were building a toolkit, and as sort of an independent study, I had to go off and learn a little something about operating system design and theory. And every time I saw an operating system, there tended to be characteristics that I wish it had that multics had in the first place. I already alluded to the fact that the engineers and we conceptual thinkers had an interesting relationship. And when you are trying to do this in general, you can think of three basic time sequencing. One is you can have the engineers go and then think about it conceptually when they're done. Well, the downside here is that they've painted you in the corner, you're hosed. You know, you have the same problem if you have the conceptual people go first and the engineers later, because the conceptual engineers could define anti-gravity, and then the engineers are in trouble. They can't do it. What we did, and I didn't talk about it so much, but the third volume that I did, it was a refinement of the mathematical model, and there were 3 refinements. Every single one of them came from engineers saying, your early models told us to do this, and we can't. Trusted subjects, people are somewhat aware of trusted subjects. Lee Schiller went downstairs on a task, he had a PDP 1145, and they said, Securify it, use this model. He came storming up a week later. He said, you've got this star property thing that says, I can't open up things simultaneously and read from high and write down. What do I do with my scheduler? My scheduler has to read the unclassified and then write it in order to get it out, and then read the top secret out of storage and make it run. I got to read and write top secret and unclassified at the same time. So that's one example. So you know, he was indignant, and I was abashed, and I said, well, you know, you've got a good point. And so we changed the definition of star property to say you have a choice. If you are unexamined, you have this rigorous limitation. If you don't want that limitation, someone has to assure, through whatever means, that if you open up those two things, you will not do the bad thing. And the bad thing is putting highly classified stuff into a low classified object. So my view is that that's probably the right thing to do. The similar issue came up when people were doing formal verification of the Blacker system that had to go to A1. They had designers and they had formal verifiers. And they ended up with a similar kind of dilemma. You take either community and have them go first, you're going to, you know, you could paint the other people into a corner. So you really have to have them talk and sort of shuffle together forward, kind of a three-legged race approach. Now, when we had done all of this, worked all of this through, 15, 20 years, people worked on how to figure out how to do good, secure systems. The government needed them, but unfortunately, the commercial people were still not providing them. And we're stuck on kind of a Hobson's choice. The government is really rotten at building and maintaining systems. Now, they can do a skunk works, they can do a proof of concept, but the government doesn't hire people to man help desks and fix bugs and keep software up to date. It just doesn't work, has never worked. And the private sector is rotten at developing real security. I have this blank in my memory. There was an IBM guy of great renown, Bill something, who was going around at that time saying the only problem you have is personnel security. Technical security is a mirage. No, it's Bill Murray's friend. So maybe it's Bob. Yeah. Bob, the pilot with all the good stories. Right. And when one of you remembers it, just shout it out. It'll be great. What the private sector is trying to do is take over the marketplace and make money. And at that time, the marketplace was IBM. That was the marketplace. Now, this is at the time that mini computers were coming out, and not too long until we had smaller computers. So what does the government do when the commercial systems don't work, they're not giving you real security, and it doesn't work for you to do it? Well, there are only sort of two choices. You can go to the commercial people who build a system that you're otherwise happy with but doesn't have security, and you can write them a contract, pay them money, and they can make you a special version. But the downside is, a couple of downsides. One is that the sharpest people don't want to work on that job. They want to build the next operating system, get their name on the new system that goes out. So you don't necessarily get the top people. But they finish it up, time passes, new version of operating system comes out, and they didn't do yours. So every time the system gets updated, you get to pay them again. Well, that's suboptimal. Doing it themselves, that doesn't work either. At that time, Steve Walker, who had been at ARPA and then was Director of Information Systems at the Undersecretary for RDT&E, decided that there was a third way. And he started something called the Computer Security Initiative. Is this familiar to anybody, the term Computer Security Initiative? There are three parts to it, but this slide has to do with his trying to explain to people how the world is going to change. This is the way in DoD that you procured systems. Time goes down. You start with requirements and you move through this set of steps, specifications, system, and then you get up to a decision point where you need to certify. And you're certifying against a set of explicit requirements and implicit ones that are included by reference. You know, FAR and DFAR and various things that that you have to do in your system. It turns out that a number of these things that you have to certify against relate to security. So the technical engineers who were brought in for this procurement have to master those areas of security well enough to get through. But I've done an acquisition, one acquisition, and everybody I knew who was a technical engineering officer, they did one, and when they were finishing, what they said is, I'm never doing this again. I'm managing my career. I'm never doing an acquisition again. As a result, the good technical officers doing acquisition are always doing it the first time. So even for the security areas, they're doing it for the first time, and some of that stuff is hard. So this is what Steve's suggestion was. This is how we're going to change it. What he said was, what we will do is set up another place, a center, that will do the things that program managers, program officers won't do. Look at the commercial products, determine their security properties. In fact, we will determine it against a standard, except we couldn't call it a standard, so it's a criteria that allows us to say these are the characteristics of these systems. We will then put it on a list called an EPL, name chosen to sound like preferred products list because people are used to the preferred products list. And then these poor engineers who got stuck on an acquisition will only have to deal with what does it mean for this system to have been a B2, and not have to deal with the 3 or 4 other things that are sort of interrelated and overlapping. So that's the plan. So the notion is we will build our criteria, we'll find a place where we get people to look at products and build this EPL. And they won't be under the time pressure of doing an acquisition. The other running joke for acquisition officers was that if you looked at what you were doing, always a tight schedule, and you'd see some technology or some approach that's really promising, first thing you looked for was, has anybody else done it and gotten certified? Because if you haven't, that means if you adopt that approach, you introduce risk. I'm not going to introduce risk because you get graded on doing it on time. So the joke was everybody wanted to be second. This is a great idea, George. Why don't you do it? Because if you do it, I can cite you. As a result, nobody did it. Nobody did the selfless acts that would help the community because they weren't being graded on that. They were being graded on coming in on time. So the notion was that the center, they would do the selfless acts. That'd be their mission. Well, Steve wasn't sure where to put it, but he got fooled by Bobby and then it ended up in NSA. And that's where I ended up going. Now, if we talk just briefly about the why my computer won't talk to him. The criteria was the Trusted Computer System Evaluation Criteria, commonly called the Orange Book. Overall, what we had in here was a distillation of 20 years. And these were 20 years of thinking about it and, in some cases, actually writing code and getting things to run. People who have one idea arguing against people who have published about a different idea. You know, interchange the marketplace of ideas. You have to define what security you want. The Orange Book said, you know, these are chunks of security we are interested in, we're the military. You need a good conceptual design. It said you will have a model. You need a faithful implementation. In one particular case, somebody who was going through the evaluation, was, conceptually they're sitting there, and the evaluators say, "Do you have a model?" They say, "Yep, got this one." It happened to be Bell Lapatula. Most of them were Bell Lapatula. They say, "You got a design?" Say, "Yep, got a design." Do they relate to each other? We don't know. Well, if you have a really good conceptual design for a chess playing program, but you're doing World of Warcraft, then that conceptual design really has nothing to do with your design. It's the faithful implementation. Show me that this actually informed your design, or that you're consistent with it. So it needs to be a faithful implementation. Write down what you've done so that a third party can check your work. Now, the last piece, there are a number of things that are in the Orange Book that many of them have sort of funny terms. I didn't understand them, so I'd go around to these various people and say, "What does this mean?" And then they'd explain, "There's this attack, and this set of words is supposed to stop this attack." And it was kind of fun. I'd go to 3 different people, and they'd give me 3 different stories about what these words were for. And so I figured, well, okay, the truth's in the middle somewhere. They made this ambiguous on purpose. So they listed the countermeasures: trusted distribution, trusted recovery. Now, when I read that one really carefully, I went into Marv and I said, what this says is that when the computer loses its tiny mind, it will come up secure. If it lost its mind, how does it know? And he explained the attack. Now, this is very good in distilling what happened over 20 years. Oh, Lord. No, I've still got some time. Unfortunately, it doesn't allow you to do things in a timely fashion. If it takes 20 years to deal with something new, then you're going to be way behind the curve. And little did we know that at the time it was published, things were speeding up. Networks were coming online and becoming more important. Databases were becoming more important, and design cycles were getting quicker. So this became a problem. This is my wife's favorite. We knew how to build the very best computers. The computers that made this ranking have never been broken into. None of them have ever had a security patch. But practically speaking, you cannot have a policy for people who want to sell to the DoD that we won't buy it unless you have made this top level called A1. You needed a growth path. So what the Orange Book did was to show A1 and then attenuate in a graceful way back to commercial systems. My wife refers to this as an exercise in partial credit. So that's really good. That's commercial practice. Commercial practice is Windows and Trusted Solaris. And those are the ones right now that are supposed to be protecting the dikes. Okay, so even though we changed the modeling kit as we went, and we had the network problem, I think I've already said that. Not going to go through this. Other things came up and I would look in the toolkit and say, sometimes I would say, we have all the tools we need. Other times I'd say, not quite. Need to add something, little bits and pieces. But rather than throwing something out of the toolkit, what we kept doing was refining or sharpening. Now, what does one do if one's an evaluator and you don't know how to deal with networks? And it's 1983. People bring you products that have networking characteristics, and they want you to evaluate it. You can evaluate not knowing what you're doing, or you can say, we don't know how to do that, we're not going to do it. Okay, well, the prudent thing is the second. Don't do it. Unfortunately, networks were not going away. So, what do? Well, in that case, we'll just make them isolated. Everything on the left is single level, trusted, top secret. Everything on the right, secret. The difficulty is that there are operational reasons they need to be connected, at least a little. Now, when people put their isolated networks up, sometimes they neglected to put that little line in. And if they did, it was kind of a little tiny faint line, but it really should be highlighted. And the reason is this is something that everybody knew, but when I finally wrote it down, Roger Shell said, glad you said that because people are just not paying attention. I call it the Computer Security Intermediate Value Theorem. We've got two spots, A and B, that are at a security level, alpha and beta, and they're different. What this says is you run any path from alpha to beta, A to B, you will hit one node that is multi-level in the sense of processing information of more than one security level. Okay? Proof is easy. It's a sketch. Suppose false. Mathematician in me comes out. Suppose false. What that means is that every node is single level. So whatever it gets, it hands out. Okay? So A hands out alpha, alpha, alpha. Next one, alpha, alpha. When it finally gets, it doesn't matter what path you take, when you finally get there, B gets an alpha. But we said alpha's not beta. So what that means is no matter how you go, somewhere there's a multi-level node. So let's go back to our min security. Everything on the left is top secret single level. Everything on the right is secret single level. Our theorem says some place has got to be multi-level. Where can it be? It's in the middle. So we have isolated networks, we hook them together, but we know how to put really strong computers in these places. So all we have to do is put really strong computers in those places, but unfortunately, these are the ones we've got. Now, if you are looking for a target, if you're the bad guy and looking for a target, oops, we just lost all of our lights, and you wanted to get from secret to top secret, where would you aim? Right at the dike in the middle. 21st century challenges. The NSA Computer Security Center is not acting as an effective champion anymore for strong commercial operating systems. They are not performing their selfless acts of security. And the hard-won accomplishments, we had 3 products that came out on the very top, and no one would use them. And now NSA will not ramp them and update their evaluation. Government is competing with industry with sandbox systems that they are unwilling to subject to the marketplace of ideas. And recently they have been issuing guidance that says the only thing you're allowed to do is one of our sandbox systems. This talks about robustness, but separation kernel bothers me more. So what can we do? We have to tell ourselves the truth, that there is a problem, and the people who tell us we're safe and secure, either they are unaware that we're not safe and secure, so we don't want to listen to them, or they know when they're telling us we're safe and secure and they're lying to us. Not many good choices there. And wherever we can, we should be making use of what's there, because it won't be there forever. And I'm almost to the point that I'm afraid it's gone. If you go to the website and punch these buttons, you find my answer. For the last 15 years, I've heard people say these statements, usually in a place where I couldn't jump up and disagree. But I have disagreements on the website. Okay, the my standard ending. You have told us everything that's wrong, so what would you do, smart guy? Well, reference implementations, I say. If you were doing something, I should have changed Yahoo to Facebook. Update this. If you are trying to let people get off to files or off to the web or to databases, and you're doing it the Yahoo, Facebook kind of way, you know how to do that. There are problems, you know, the other kinds of problems, but from that kind of security, we don't have to do that. If you attach your, to two things where one's top secret and one's secret, it's a totally different ballgame. It is not just more of the same functionality. But we have known for 20 years how to build that box in the middle to do secure databases and file storage, and it's easy enough to do webs. What needs to be done, I have said over and over again, and once or twice I've had people say, I think I've got the money for this. Somebody needs to go off and build these and demonstrate them. The only hard part of this is compiling Oracle to run on a small box. Dumb compiler tricks are the only hard part. The cost of a source license is significant, but if the government bought it once, the government could use examples anywhere. We need a selfless act of security. Now, I've heard some mention of U.S. visit. I haven't heard, I don't know the details recently, but I talked to the ISSO, I think was the terminology, in 2003, just as U.S. visit was coming up. This is the visitor immigration system that keeps track of everybody. He came over to me, he was introduced to me, and we were talking, and he said, you know, this is what I need to do in U.S. visit, and what I need is something that's at least B2. And our security people looked around and said, you don't have many choices. The general idea is that there are intelligence groups, law enforcement, visa offices in Cairo and places like that, customs people and various public sources who have information, and people at these various places need to have access to some of that information. Not all of it, but some of it. So what you'd like is a nice set of equipment that you could put places, configure for your individual location, that would enable people to put things into the database if that's their job, and retrieve stuff from databases if that's their job. And for a passport officer, for example, to check to see if there's any reason to deny a visa, and if there's not, to issue the visa, and then record the visa was issued, so that other people could look at it, like customs. So this is sort of one site. So you need to put files over here. You need a database, might or might not have to be multi-level. In the aggregate, it is. You need to be able to read up, so things down below you can suck it in. You have to have a limited way of providing stuff out when it's your function and your job to put stuff out. Do web, file stuff. We know how to do all of that. Somebody needs to build it and then say, you need this kind of thing? Do it. It isn't so hard. I always said that if my retirement nest egg was bigger, I could fund it. But then I'd have to go to work. That's it. Questions? Bob Courtney. That's it. I tried last night to go searching for it, and I forgot after I got to the back, but it's Bob Courtney. IBM was going around saying this notion of technical security is just a mirage. The only thing you have to do is make sure you have good people.
Courtney's laws actually make sense, but that part of what he used to say is off.
Yep.
But the rest of the other half of what he said really is valuable.
Yeah. Well, at the time I first observed him talking and stuff like that, I was at the Computer Security Center, so I was looking at it through blinders.
So I'll ask, there are two systems I know of that are out there that are fairly highly rated. One is Rogers' sort of redone GemSauce system. He hasn't been able to get a lot of traction on getting people to adopt that. And the other is the Green Hills Integrity System that's been evaluated at a high level. It's a very compact system. Any comments on either of those?
I knew a little bit about the Green Hills when they were first starting up, or when they were getting rolling in 2004. I'm not current on it beyond that. Rogers' GemSauce system was the basis of the Blacker system that was a combination of high-grade crypto and A1 systems, which NSA fielded in an initial run and then used for their own purposes for 10 years but never put out for anyone else. My observation is much the same as yours. He's not getting much traction. He sometimes wants more than he can get in the first step. I mean, he would be perfectly happy if he could get some agency to give everyone a laptop with GemSauce on it. My view is that we would make extremely good progress if we could make use of GemSauce in those places. I mean, the fact that we network now the way we do, and we don't have much big iron lying around, means that in those places, where, I showed you the multi-level between the isolated networks. What we currently have are things like DTW, MDDS, and there's another one, I forgot, all of which run on trusted Solaris with special changes. These are systems that are designed for cooperating people. If you put a GemSauce system in there for doing the same thing, we would start to actually isolate our networks. I don't know if he's ever going to find someone who is willing to do it. The top accreditor at, can I say that? Top accreditor at one of those three-letter agencies has said that the only game in town for PL5 is GemSauce. But he can't initiate anything. He has to wait for somebody to bring a system forward, and the people who build their systems are not doing it. So I have been worrying for some years that what we gained is going to be going away, and not to be morbid, I am afraid we're going to go to Roger's wake and talk about his long attempt to get people to use this good technology, and he won't have gotten anything further.
I think you said in the beginning that there's been one in 1974. What was that?
I planted that. Could you tell? It's what people have a number of names for it. I call it the warp speed channel. During the evaluation of a product that will remain unnamed, it doesn't mean unnamed. It was the DEC A1 system. What they found was a covert channel. That's a term everybody knows. Covert channel. They found a covert channel that worked faster than data transfer. And there was no way to throttle it back. This is another thing where people who were involved with it were so concerned because they didn't know what to do. They didn't classify it, but they refused to tell their colleagues. We were, Trusted Information Systems co-sponsored a first covert channel workshop. There wasn't a second one, with aerospace. And this had blown up just before that. And some of the people at TIS knew about it. And Ted Lee didn't, so he asked how it worked. And they said they couldn't tell him. Ted Lee, PhD from, I think, Harvard, had worked at Burroughs, which became Unisys, and was a dynamite programmer. So by the next morning, he had a covert channel that was running at 20 kilobytes a second. We were there 3 days. By the time he left, he had 120 kilobytes a second. Now, the way this works, is anybody familiar with the way that sperm whales procreate?
Do we have a video?
Hmm?
Do we have a video?
I do not have the video. It requires 3. This covert, one to prop the female up. This covert channel requires 3 processes. In the large kind of computers, for optimization, they would allow a process to specify memory to be used for something so that you could use memory that was right there, so it wouldn't have to go way over.